Imagine you give a digital assistant your credit card, and you ask it to book this really complex family vacation. Do you want that assistant to be 100% confident in its choices, even when it's totally wrong?
Yeah, definitely not.
Right. Or, would you prefer it to pause, admit it's confused about your connecting flight, and just ask for help?
Which is what a human would do, hopefully.
Exactly. So today, we're looking at how the tech industry is trying to fix this this confident idiot problem in artificial intelligence. Welcome to the deep dive.
Glad to be here.
For this deep dive, we are locked exclusively on Google's AI ecosystem updates, specifically the ones published between March 29 and April 4, 2026.
And, when you look closely at the data from this specific week, a massive industry pivot is unfolding in real time.
Oh, yeah.
Yeah. We are officially moving past the era where the only goal was building these increasingly massive cloud-bound models. This week is entirely about operationalizing autonomy and efficiency.
Okay, let's unpack this, because that sounds like a big shift.
It really is. It's about taking frontier-level AI, shrinking the compute footprint, putting it directly onto personal devices, and drastically cutting the economic cost of generation. Basically, the foundational infrastructure of autonomous AI is being laid down right now.
Right. But before we get to the shiny new products or the highly optimized APIs, we really have to look at the foundation.
Yep. The bedrock stuff.
Because if we're going to deploy highly autonomous models to personal edge devices like, the phone in your pocket, we need to know if they're actually behaving the way humans want them to.
Which brings us to the alignment problem. It's arguably the most critical bottleneck in development right now. So on April 3, the Google research blog published this massive study.
I saw that one.
Yeah, it was titled Evaluating Alignment of Behavioral Dispositions in LLMs. It was a joint effort between Google DeepMind and Google Research.
And they looked at a lot of models, right?
25 major large language models. They compared their outputs against reference data gathered from over 550 human crowd workers across the globe.
Wow. I read through those testing methodologies, and they essentially used, psychological situational scenarios.
Exactly.
They gave these models complex behavioral tests to measure human-like traits. Things like social values, moral judgments, and how they handle ambiguity.
What's fascinating here is that the study proved mathematically what many developers have felt intuitively for years. Even the most advanced frontier models frequently exhibit severe overconfidence.
They just don't doubt themselves.
Right. They completely fail to capture natural human uncertainty. When a human is faced with a nuanced situation, they naturally hedge. They say, I think, or, it depends.
Yes, you give yourself an out.
But the models, they just charge ahead with absolute mathematical certainty, even when they're hallucinating entirely.
It's like hiring an intern. You need to know if they're going to confidently give you the wrong answer instead of just admitting they don't know.
That is a perfect way to put it.
Because if an autonomous agent is going to, summarize a critical legal document for you, false confidence is incredibly dangerous. And this new research finally provides a diagnostic roadmap to fix that model reliability.
Right, but evaluating that reliability requires human raters, which leads to another foundational paper published by the Google research blog. This was on March 31.
Oh, the one about the benchmarks.
Yes. The headline is, Building Better AI Benchmarks. How many raters are enough? And it asks a deceptively simple question about how we grade these models.
Because right now, what is it? They just ask a few people, right?
Historically, the industry standard has been using 1 to 5 human annotators per test item. You generate an AI output, you have 3 people grade it on a scale of 1 to 5, and you take the average.
Which seems logical on the surface.
Yeah.
But when an AI is no longer just writing a simple haiku and is instead executing a complex, multi-step workflow, human consensus fractures?
Oh, totally.
3 people are rarely going to agree on the perfect way to organize a spreadsheet or draft a sensitive email.
Exactly. So the researchers released a new framework simulating gold standard rating distributions. And it statistically demonstrates that a pool of 1 to 5 raters completely fails to capture the natural variance of human disagreement.
So 5 people just aren't enough to represent the whole picture.
Not even close. If you want your machine learning evaluation to be reproducible, you are forced to shift toward much larger rater pools. You just have to actively account for the fact that human logic is highly subjective.
Yeah, it makes a lot of sense. So by fixing those foundational benchmarks and alignment diagnostics first, Google is basically building a safety net.
Precisely.
And having that net is what allowed them to confidently release a massive wave of highly autonomous on-device products this week, which takes us straight into the Gemma 4 launch.
Yes. The shift to the edge is materializing rapidly.
Mm.
On April 2, the Google DeepMind blog announced the launch of the Gemma 4 open model.
And they changed the license on this one, right?
Yeah, they did. Crucially, they released these under a fully permissive Apache 2.0 license. That tears down the commercial use barriers that restricted earlier versions. This is a direct challenge to the broader open weights ecosystem.
Let's break down what actually launched. Gemma 4 is a family of 4 multimodal models. You have the E2B and E4B, which are optimized for phones and small edge devices.
Right.
Then you have a 26 billion parameter mixture of experts model and the flagship 31 billion parameter dense model. And these are built specifically for end-to-end agentic workflows without requiring specialized fine-tuning.
And the benchmark scores are just staggering. The 31B model hit 89.2% on the AME 2026 math benchmark and ranked number 3 on the Arena AI Text leaderboard.
Wow, number 3.
Yeah. It is beating out models 20 times its physical size. Plus, they natively support over 140 languages, process text, audio, and images simultaneously, and feature massive 256K context windows.
Okay, wait. A 31 billion parameter model running globally on consumer hardware? How is that physically possible without melting a smartphone?
I know it sounds crazy.
I mean, or draining the battery in 10 minutes.
It comes down to 2 major architectural breakthroughs: mixture of experts and weight quantization.
Okay, explain mixture of experts first.
So, to understand mixture of experts, think of a massive hospital. A standard dense model is like one general practitioner trying to learn and process every single medical discipline at once.
Which would be exhausting.
Right. It takes massive energy. A mixture of experts model is a hospital filled with specialists, cardiologists, neurologists, pediatricians. When a prompt comes in, a routing network acts as a triage nurse.
Ah, so it only wakes up the doctors it needs.
Exactly. It activates only the specific expert parameters needed for that query. The rest of the model stays powered down, saving tremendous compute.
That makes perfect sense for battery life. But what about the physical storage space? A model that's smart usually takes up, what, dozens of gigabytes of RAM?
That is where advanced 2-bit and 4-bit weight quantization comes in. It's managed by their new LitterTLM library.
Quantization, so that's like compressing it.
Yeah, think of quantization like compressing a massive high-resolution raw photograph into a tiny JPEG. You lose a tiny bit of pixel-level detail, but you still clearly see it as a picture of a dog.
Right. The core information is still there.
Exactly. By compressing the mathematical weights of the model down to 2 or 4 bits, they keep the memory footprint of the smaller variants well under 1.5 gigabytes.
Oh, wow. So it runs entirely in the device's secure enclave. You get high-level reasoning and multi-step planning, but your personal data never gets beamed up to a cloud server.
Which is a massive paradigm shift for user privacy.
Yeah, it really is. But obviously, not everything can run on a phone. When you want to generate something incredibly compute-heavy like high-definition video, you still need the cloud.
You do, and cloud compute is expensive, which has been the primary barrier to enterprise adoption of generative media.
Which brings us to the March 31 announcements.
Right. The Google Cloud blog and Vertex AI release notes announced Veo 3.1 Lite, alongside a new standalone 4K video upscaling feature.
Veo 3.1 Lite is positioned as the most cost-effective video generation model to date. It supports text-to-video and image-to-video in both 720p and 1080p.
And you can do custom durations of 4, 6, or 8 seconds.
But the crucial metric here is the pricing, isn't it?
Oh, absolutely. They priced Veo 3.1 Lite at less than 50% of the cost of the standard Veo 3.1 fast model. And they did that while maintaining the exact same generation speed.
Half the price. That's a huge cut.
They achieve this by optimizing the diffusion steps and shrinking the latent space the AI has to process. When video generation costs are suddenly cut in half, high-volume programmatic creation becomes economically viable for developers.
I can see that. Imagine an e-commerce platform dynamically generating thousands of personalized product videos on the fly.
Exactly. And Google didn't just release this API for developers to play with. They immediately integrated it into their own consumer suite.
Right. On April 2, the Google Workspace blog announced that every single Google account holder now receives 10 free AI video generations per month using Google Vids, which is powered by Veo 3.1.
And they paired that with custom music generation using the Lyria 3 audio model.
That's a lot of creative power for free.
It is. And for paid AI Pro and Ultra subscribers, they unlocked up to 1,000 generations a month alongside directable AI avatars.
Oh, the avatars. Those are wild.
Yeah, these avatars are capable of maintaining consistent facial identity and voice characteristics across entirely different scenes.
This makes Google the first major platform to offer frontier-quality, studio-grade AI video generation completely free to billions of users.
They are deeply instilling this capability into daily productivity.
Yeah, I mean, you aren't just typing an internal memo anymore. You are prompting a fully produced, dynamically scored training video.
But delivering that kind of rich contextual application requires an incredibly robust back-end infrastructure.
Which brings us to the developer side of things.
Developers building sophisticated AI tools need reliable, low-friction ways to connect models to private data. That is why the launch of the Vertex AI RAG Engine serverless mode on April 3 is so significant.
Let's clarify RAG for a moment. It stands for retrieval-augmented generation. Basically, it's the architecture that lets an AI model take an open book test.
Good analogy.
Instead of relying solely on whatever it learned during its initial training, RG allows the AI to securely search through a company's private documents or databases in real time to find the exact answer.
Right. But building a RAG application historically meant a developer had to manually provision, scale, and manage a separate vector database.
Which is a pain.
Huge pain. You have to store all your document embeddings, which is just a fancy way of saying you translate your 50-page PDF into a map of mathematical coordinates so the AI can understand it. Managing that database is a headache.
So with this new, fully managed serverless mode on Vertex AI, Google is handling the storage of those embeddings internally. They're using their massive Spanner database infrastructure behind the scenes.
Yes, developers can build complex RAG applications without playing database administrator. You just point the engine at your data, and you pay only for the inference you actually use.
Cost control is clearly the dominant theme across all these releases. We see it with Veo Lite's pricing, we see it with serverless RG abstracting away database overhead, and we saw it applied directly to the core Gemini APIs.
That's right. On April 1 and 2, Google AI developer documentation detailed new Flex and priority inference tiers for the Gemini API.
The Flex tier is cost-optimized. It is perfect for offline, batch-style workloads where a little latency doesn't matter, like, say, analyzing 10,000 customer reviews overnight.
And the priority tier is latency optimized for real-time interactive applications where the user needs an instant response.
But there was a more critical update in there, too.
Yeah, the introduction of mandatory monthly spend caps at the billing account level. Tier 1 users are now capped at $250 a month, with limits scaling up for enterprise tiers.
If you've ever woken up in a cold sweat realizing a runaway line of code on a weekend project just racked up a massive cloud computing bill.
Oh, the worst feeling.
Right. This $250 hard cap is basically a developer's security blanket. Back in March, a billing bug caused some developers to face tens of thousands of dollars in charges for unused services.
Exactly. These mandatory caps give granular control over cost-performance trade-offs and provide a hard safety net against unexpected API consumption spikes.
It is entirely about building trust in the platform.
Trust is everything right now, and trust is the perfect bridge to our next topic. When you give billions of people free studio-grade video generators and you deploy highly capable autonomous agents locally to personal devices, governance is no longer a hypothetical academic exercise.
It is an immediate societal imperative.
On April 1st, The Keyword, that's Google's main blog, published the 2026 Responsible AI Progress Report from Google Trust and Safety.
I saw that. It details the application of their AI principles over the past year.
This report is vital because it provides the official transparency framework for how Google is managing the transition we've been talking about.
Moving to agents.
Exactly. We are moving from simple generative tools where you type a prompt and get a picture to proactive agentic systems that can plan, reason, and execute actions across the digital world. The risk surface area expands exponentially when an AI can take actions on your behalf.
It's one thing to generate a bad image. It's another thing for an agent to accidentally email your entire contact list or, like, misconfigure a server.
If we connect this to the bigger picture, this comprehensive progress report serves as Google's preemptive defense against escalating global regulatory scrutiny.
Because regulators are definitely watching.
Oh, closely. The European Commission has formally initiated an antitrust probe into AI search tools, and regulators worldwide are scrambling to understand how to govern agentic AI. Google is attempting to put hard documentation in front of lawmakers, demonstrating that their internal safety protocols are robust enough to manage this transition responsibly.
But corporate self-regulation and slick progress reports only go so far when public sector infrastructure is lagging decades behind the technology.
That is very true.
On March 29th, the Google.org blog announced the launch of a global $30 million fund for the AI for Government Innovation Challenge.
This initiative provides funding and engineering support to public sector organizations using AI to address health, climate resilience, and economic opportunity.
Right.
It targets a massive adoption gap identified in their research. 80% of public servants want to use AI to improve services, but only 18% feel their governments actually use it effectively.
Okay, I have to push back on this a bit. Is $30 million across the entire globe actually enough to modernize massive, entrenched governmental bureaucracies?
It's a fair question.
I mean, that is practically a rounding error for a major tech company.
Yeah.
Is this really just a strategic philanthropy play about seeding Google's proprietary ecosystem and developer tooling into foundational public infrastructure?
That is a very common and valid critique in the industry. $30 million is a drop in the bucket compared to national IT budgets.
Right.
But the goal of programs like this is rarely holistic modernization. It is about creating high-visibility proof-of-concept projects. If Google can help a municipal government cut emergency response times using Vertex AI, that becomes a powerful case study.
Ah, so it's a showcase.
Yeah. It builds familiarity and reliance on the Google stack, which paves the way for highly lucrative enterprise adoption down the line.
And modernizing government software infrastructure is really only half the battle. The other half, the arguably harder half, is ensuring the actual human workforce knows how to interact with these new tools.
The AI Works for Britain initiative addresses exactly that. It was launched by the Google Europe blog on March 31.
That's the upskilling one.
Yes, it is a nationwide upskilling program backed by £2 million in grants designed to teach practical, applied AI skills to the UK workforce.
The initiative was built around a really striking finding. 76% of UK workers feel stuck in their careers.
Which is a huge number.
That is a massive portion of the population feeling like they have plateaued. Google is positioning this AI training not just as corporate software training, but as a tangible equalizer.
They are targeting the middle layer of the workforce. It isn't just about teaching software engineers how to code better.
Right.
It is about teaching a mid-level marketing manager how to use predictive analytics to map consumer trends, or teaching administrative staff how to automate their data entry so they can take on higher-level strategic work.
It is offering a way for individuals to break out of career stagnation and unlock professional progression through technological leverage.
Precisely.
So what does this all mean? If we step back and look at the staggering velocity of this single week, we've seen Gemma 4 push high-level reasoning to our phones. We've seen Veo 3.1 Lite democratize studio-grade video creation.
Yep.
And we've seen the hard policy and workforce governance required to actually align these systems with human needs.
Google is rapidly building the infrastructure for a world where AI is no longer just a search box you query. It is becoming an ambient, autonomous collaborator that works alongside you in the background.
And that ambient collaboration brings us to a final critical question. You mentioned earlier the research on evaluating model alignment, but there was another study published by the Google Research blog on March 31. It was exploring the cognitive cost of AI assistance.
That study is perhaps the most profound piece of literature released this week.
Tell us about it.
The researchers conducted controlled experiments and found that while AI assistance undeniably boosts immediate task performance, there is a hidden psychological cost.
A cost to us.
Yes. Participants who relied heavily on AI to solve problems and then later lost access to it performed significantly worse on subsequent tasks.
Worse than if they had never used it.
Yes. More concerningly, they gave up much faster than participants who had never used AI at all.
Wow. So as Google puts powerful, autonomous agents natively on our phones and gives us one-click video creation in our daily workspaces, we have to ask ourselves a hard question.
Exactly.
Are we using this incredible technology to scaffold our own competence and learn new skills? Or are we actively de-skilling ourselves, trading our long-term persistence and cognitive resilience for short-term efficiency?
It is the defining question of the agentic era. The tools are here, they are incredibly cheap, and they are autonomous. How we allow them to shape our own capabilities is entirely up to us.
It really is. Thank you for joining us for this deep dive into the source material. We covered a massive amount of ground today, from weight quantization on edge devices to the psychology of human raters. Keep analyzing the tools you use every day, keep unpacking the architecture behind them, and above all, keep questioning the information around you.